All right, 8th graders, how you doing? Hope you're doing well. I got a little demonstration here. I got a little wave tank. It's just plastic, but there's a divider in here, and this would have been an activity that we would have had you do in class. That's a little better for that, but then this is the exact equipment you would have used. And there are little stands here that support on the ends, but we've got the wood here that also support it as well. Okay, I've got red representing the hot water, and I've got, or warm, good warm water, and then I've got blue, which I know you're not seeing it too well right now, but the blue represents the colder water, and so it's all relative how warm or cold. But there is a difference between the two temperatures here, and so I want you to think about what's going to happen when I pour in the two types of water on each side. So I'm going to definitely separate. Again, there's a divider here. All right, and you'll probably see a little leakage between the two. It's not perfect, but it does pretty well. All right, so here we go. I'll pour this in here first. And I'm going to try to get them the same height the best I can. And you can all see that it started to leak if you're watching closely. And that's pretty close. All right, so right now you've got blue, cold, or colder, in red, warm, or warmer water. And it's pretty close to the same height. It's not perfect, but see if I can top it off just a hair here. All right. So anyway, I want you to think what's going to happen when I lift this divider. So again, red, warm, blue, cold. What do you predict is going to happen? What's going to be the movement in the tank? What is it going to look like after I lift this up? Okay? All right, so here we go. And again, it doesn't take too long. Try not to disturb it any more than necessary there. So right away, again, the water is representative of air. That's what we're trying to get across here, dealing with air pressure in this case. But it does apply to water pressure in the aspect of higher or low pressure. But you can definitely see the blue is sunk to the bottom. It's settled to the bottom. There's kind of that boundary between the blue and the red where it's a little bit of mixing, probably purplish in that area. And then you've got red at the top. And there's a little bit of motion back and forth, a little bit of seesaw effect here. Okay, but is this what you predicted, that the red would be at the top? The red warm, less pressure. Less pressure rises, the greater density comes in and pushes it away. So the cold blue water is more dense, pushes underneath the red warm water that's less dense. So hopefully that's what you predicted. And that's that little demonstration. It's pretty good little demonstration if you're doing it yourself particularly. So, all right. Hello, 8th graders. Got another demonstration. It's real similar, of course, to the one that you saw hopefully last time. This time I've got hotter red water and I've got colder, in fact, ice cubes in here. It's much colder and I had to use green. Sorry, I'm totally out of blue. So I've got green food coloring representing the cold water. And again, it's much colder and this is much warmer. So I want you to think what's going to be the difference between the previous video compared to this one. Okay? So just a reminder, in case you did it the wrong way and you went the wrong order, we do have a divider in here and stands supporting this little wave tank. And again, you would have done this in class. So, all right, we'll pour the green cold in and be thinking about what would happen when the divider is picked up. We'll try to put the same quantity of water in each side. Put my nice little mitt on here. Nah, we'll just grab it. It was almost boiling, but I'm gonna try to get the same quantity in there, and that's pretty close. All right, so make your prediction. What do you think is gonna happen? Hopefully you're not seeing it already because I can see something moving. But cold, hot, and how fast will this happen? Now, is this moving at a different speed than what we had last time? Is it moving faster or slower? And why is that? So if you watched the other video already showing the warm and cold water versus the hot and ice cold, this one should have moved much, much quicker. So why is that? Why does it move much quicker? And what does that really represent? When we think about the air, and again, the water is representing the air. So if that's the air inside here, and it rushed through there, if you were in here, if you were part of outside, what would you have experienced? Would you have experienced really slow winds, fast winds, or whatever? So, all right, and that's it.